Question number 66, which of the following options is correct? Students, carefully having a look at the question. If I consider my function fx to be equal to sin x minus cos x, if fx is sin x minus cos x, what is f dash x? F dash x is cos x plus sin x, and that is root 2 times sine of x plus pi by 4. Sine of x plus pi by 4 will be positive when x belongs to 0 to 3 pi by 4. So this f dash x will be positive when x belongs to 0 to 3 pi by 4 at least. Okay, let us consider this small interval. 3 pi by 4 is a value which is slightly greater than 2. Okay, so now all the options contain either root 3 or 2 or 2 root 2 or root 2. My interval is safe if I take the interval as 0 to 3 pi by 4. Fx is an increasing function in this interval. First condition, f of root 2 greater than f of 1. Second condition, f of root 3 greater than f of root 2. Third condition, f of 2 greater than equal to f of 2 greater than f of root 3. So carefully looking at the options, sin root 3 minus cos root 3 is equal to cos sin 2 minus cos 2. Very wrong. Sin root 2 minus cos root 2 greater than sin root 3 minus cos root 3. Again wrong. Sin root 2 minus cos root 2 less than sin root 3 minus cos root 3. Very correct. Fourth option will be wrong. Because sin root 3 minus cos root 3 is less than sin 2 minus cos 2. Okay. So answer is option number 3. So if you consider a function fx as sin x minus cos x, you will be easily able to evaluate this particular problem. Very smart one. Let us move on to 67.
Question number 67 says that consider a function fx is equal to 1 plus sin x whole multiplied with 1 minus cos x. Then we have to identify that which of the following options is incorrect. So students, the options are talking about points of extremum, local extremum, point of inflection, range. So let us analyze this function by taking its derivative. We can see that fx is equal to 1 plus sin x minus cos x minus sin x into cos x. So let us calculate f dash x and put it equal to 0. Differentiation of 1 is 0. Sin x is cos x. Minus cos x is sin x. Differentiation of sin x is cos x. So cos square x. And this is sin square x. So if you put f dash x equal to 0, I will get sin square x minus cos square x plus sin x plus cos x equals 0. So students, we can easily see that first term is a square minus b square and second term is a plus b of the same format. So a plus b is common, sin x plus cos x is common, whole multiplied by sin x minus cos x plus 1 equals 0. Now students, there are two possibilities. Sin x is equal to minus cos x. That means tan x is equal to minus 1. And in the interval 0 to 2 pi, we have two values, 3 pi by 4 and 7 pi by 4. From here, if this second bracket is 0, I am getting cos x minus sin x equal to 1. Which will happen at 3 points, x equals 0, x equals 3 pi by 2 and x equals 2 pi if we talk about the interval 0 to 2 pi. Students, we know that fx has two trigonometric functions which are periodic with period 2 pi. So if we analyze this particular function in the interval 0 to 2 pi, we have analyzed it as a whole. Okay. So now by the analysis of first order derivative test, we can conclude that x equals 0, x equals 3 pi by 2 and x equals 2 pi are points of local minima. X equals 3 pi by 4 and 7 pi by 4. Both are points of local maxima. This is an obvious saying that for a continuous function, between every 2 points of local minima, there exists a point of local maxima. So between 0 and 3 pi by 2, 3 pi by 4 is the maxima. Between 3 pi by 2 and 2 pi, 7 pi by 4 is the local maxima. Students, we can easily see that option number 2 is incorrect. Obviously, you can validate all the other options because range of fx will be 3 pi by 4 is the point of local maxima. Okay, and x equals 0 is the point of local minima, and x equal to 0 give you the minimum value. So the range is from 0 to 3 by 2 plus root 2, which is a correct option. That is why it will not be my answer. Number of points of extremum lying 5, correct. X equal to pi by 2 is not a point of local extremum. It is true. So again, not my answer. So by simply differentiating this function and putting it equal to 0 with the knowledge of trigonometric functions, we have solved it very easily. Okay, let us move on to next question.
Question number 68 says that the number of points of discontinuity of the function fx is equal to the modulus of greatest integer of sin x plus cos x lying in the interval 0 to 2 pi is. Now students, first of all pay attention, it is an open interval. Second thing, every one of us know that sin x plus cos x can be represented as root 2 times sin of x plus pi by 4. So let us straight away draw the diagram. This is the coordinate axis and the graph of sin x plus cos x will be made by using two transformations. Sin of x plus pi by 4 will be shifted pi by 4 units to the left, and just because there is a factor of root 2, the values will be magnified to root 2 and minus root 2. So the graph will be something like this. This value is minus pi by 4. We have to look for the interval 0 to 2 pi. This value is 2 pi. This value is 3 pi by 4. The function is sin x plus cos x, greatest integer and then modulus. And I have transformed it into root 2 times modulus of greatest integer of sin of x plus pi by 4. We all know that this value is 1 at x equals 0. This value is root 2. This value is minus root 2. We know that greatest integer of any function is discontinuous at all those points over where the function attains an integral value. So let us draw the lines, horizontal lines, y equals 1, y equals minus 1, y equals 0, and count the number of points of intersection, because all those points will be the points of discontinuity. This is point 0, so 0 is an open interval. First point, second point, third point, fourth point, and fifth point. This value is also 1, no doubt in that. But again, this point is 2 pi, so it doesn't matter. It is not included in the interval. Believe me students, when you take the modulus of the same thing, there will be no change at all in the points of discontinuity. So we have option number 1 as the correct choice. Okay, let us move on to 69. Question number 69 says that the equation of the tangent to the curve 1 plus x square into y is equal to 2 plus x where it crosses the y-axis. So if it is crossing the y-axis, put x equal to 0 to get the coordinates of that point. Putting x equal to 0, I'll get y equal to 2. So the point P where I need the equation of tangent is 0, 2. Let us calculate the slope by differentiating the curve. The curve is y plus yx square is equal to x plus 2. Differentiating the curve and putting 0, 2 in over here. So y dash plus 2xy plus x square y dash equals 1. X is 0, so these two terms are 0, y dash is simply 1. Equation will be equal to y is equal to x plus 2. Simple, option number 4 is the answer. Okay, slope is 1, point is 0, 2, so y equals x plus 2. Let us move on to question number 70.
Talking about question number 70, it says that if integral of sine cube x into cos x into 3 minus cos square x into e raised to the power sine square x dx is equal to 1 by 2 into fx into e raised to the power root fx, then what is fx is equal to? Students, if we put sine square x as t over here because it is e raised to the power sine square x, we'll hopefully manage the other terms. So if sine square x is t, 2 sine x into cos x dx is dt. Now students, arranging the terms properly, I have 3 minus cos square x is 2 plus sine square x. This sine cube x can be splitted sine square x into sine x into cos x, which will be used in dt, into e raised to the power sine square x dx. We are going to put sine square x as t, so this is e raised to the power t into t plus 2 into dt by 2, according to the substitution I have just mentioned. So this is e raised to the power t square plus 2t, so e raised to the power x into fx plus f dash x? The answer is 1 by 2 e raised to power t into t square. Okay, plus c. The answer is e raised to power x into fx plus c. So 1 by 2 was a constant common outside, so it will be there. 1 by 2 into fx. So fx is t square. Fx is t square because e raised to power root fx is there. That means e raised to power t is there. So confirmed. Fx is t square. T is sine square x. So fx is sine power 4x. Carefully and smoothly applying trigonometric substitution, we have arrived at a conclusion that option number 4 is the correct choice. Okay. Let us move on to 71.